Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is, I know you're probably sick of hearing this, one of the most important videos in all of trigonometry. At the beginning, there's a lot of those, so it's excusable that I say that. But reference angles honestly are super important because they reduce the complexity of a problem. So let's talk about reference angles and then I'll showcase why they're super important. So given an angle theta, its reference angle, theta hat is what we would call that. Let me go ahead and point that out, is the measure of the smallest positive acute angle formed by the terminal side of theta and the horizontal axis. Now, I know if I was a student and I was reading that, I would be like, say what? I'm sorry, I totally don't get that. So let's go ahead and actually show you a picture of this. Let's say we have an angle carved out here called theta. There's theta right there. Let's make it a little more obvious. There's theta right there. Okay. So theta is that angle that opened up in this direction. It's a positive angle. And we want to know what its reference angle is. Now, visually, if you can imagine, there is a set of axes here. There's the y-axis. Goes both directions, obviously. And there's the x-axis. It goes both directions, obviously. Okay. The reference angle is the fastest way to get from the terminal side all the way to the x-axis. This angle right here we would call theta hat. It is, again, the fastest angle to get to the x-axis. A lot of people want to memorize things about the reference angle when they first see it. I'm telling you, don't bother. It doesn't really matter to memorize it. It's not going to help you. So if, let's say this was theta, again, imagine that there's an xy axis. It is the fastest angle to the x-axis, not the positive x-axis, just the x-axis. Doesn't matter if it's positive or negative. Let me show you one where it might be the positive x-axis. So again, you have some angle, let's just say it rotates all the way out to here. That's theta. Again, from that terminal side, the fastest way to get to the x-axis is this angle right here. So that is what we call theta hat. It's not going this way. It's not going to the y-axis. It's only going to the x-axis. I've seen students try to draw reference angles to the y-axis. There's no such thing. So don't ever do that. It doesn't work out. Little note I have here. Reference angles are always considered to be positive, even if they open clockwise. That is critical to note. Reference angles will always just be considered positive angles. And that's because we use them for intermediate level mathematics, in between computations. And we just need those things to be positive. So this is very important. All right, let's go ahead and move forward. State the reference angle for the given angle. So let me give you some examples. I give you an angle. And we'll start with degrees because everybody loves degrees for some weird reason. So theta is equal to 170 degrees. Well, it's probably a good idea to draw it out. I always recommend that to my students. Just draw it out really quickly. It doesn't really hurt you. It's only a moment to do. 170 degrees is almost to 180, but it's not exactly. The fastest way to get to that horizontal axis is through a 10-degree angle. That's what you have left over. It's like the stuff you didn't get through to get to the axis. So the reference angle here, which I'm butchering the theta, let me jump into that. The reference angle for 170 degrees is 10 degrees. It's the fastest way to get to the x-axis. Trust me, people see this and they initially think, I have a lot of students that look at this and they go, super easy. And then they go to do it and they're like, wait, what is going on? Why can't I do this? So that's why I'm going to spend a little extra time here. Suppose that you have instead theta is equal to a negative, let's say negative 210 degrees. Keep picking on the same quadrant, to be honest with you. What does that mean? So we're going to rotate backwards past 180 and a little bit more. And if you've noticed in all the videos I've done, I say that quite a bit. We do this and some more, right? We rotate 180 degrees backwards and a little bit more. It's that and a little bit more that ends up being our reference angle. What is the little bit more? So again, this was 210 degrees with a negative. To this point right here was 180. So what did we have left over? Well, we had an extra 30 degrees in there. So this reference angle right here is a 30-degree reference angle. So theta hat, in this case, would be 30 degrees. Again, very important to be solid with this skill. All right, let me give you another one here. What do you want? Radians. Okay, let's do radians. Let's do 5. No, let's not do that one. Let's do 11 pi over 6. So theta equals 11 pi over 6. Now this is going to challenge you, and I'm going to actually draw in an XY axis just because I want to, no other reason. And we want to open an angle positive through the angle of 11 pi over 6. Now remember, here is 6 pi over 6. Over here, if we rotate all the way around, is double that, 12 pi over 6, which is 2 pi. Did we get all the way to 12 pi over 6? No, we only went to 11 pi over 6. So I guess our terminal side is just this guy right here. That's 11 pi over 6 is the green ink, 11 pi over 6. But what did we not get to? We got 11 pi over 6 almost to 12 pi over 6. We're just shy of it by a single little pi over 6. Notice those denominators, they're all the same. That's the trick with radians. Get everything in the same denominator. So we can just go back over here and say the reference angle for this is theta hat equals pi over 6. Let's do another radian one because I want you to see a pattern that develops with radians. It's not always the case, but often the case. Let's suppose that we have theta is equal to, let's do 2 pi over 3. Picking on very special angles. So 2 pi over 3. Well, that is not all the way to 3 pi over 3. Remember, this is 3 pi over 3 right here. So we're just shy of that. All right, about to there. We're shy of that by how much? Well, let's see. This was 2 pi over 3. That's the angle in radians. And we're shy of it by, or shy of 3 pi over 3 by a single little pi over 3. So our reference angle must be a single little pi over 3. And some people will say, how did you know 2 pi over 3 landed in quadrant 2? And the response to that is because I just know. But also, if you think about this being 3 pi over 3, then it cuts this into thirds. So that here is 1 pi over 3. This is 2 pi over 3. And then if you've gone all the way, it's 3 pi over 3. That's how I knew that it was landing in quadrant 2. So anyhow, but I want you to notice with degrees, there's not really a super huge pattern with their angle versus their reference angle. 170 degrees is the angle. Oh, 10 degrees is a reference. I mean, it doesn't seem so obvious. Negative 210 degrees is the angle. 30 degrees is a reference angle. Again, nothing super obvious there. Radians, on the other hand, 11 pi over 6 is the angle, pi over 6 is the reference angle. 2 pi over 3 is the angle, pi over 3 is the reference angle. It will not always be that way, but it will often be that way, where the reference angle is basically pi over the denominator. It will not always be that way. I want to accentuate that here. I'm going to give you one last one. This is not a special angle. 9 pi over 8. I love these styles of angles to give on exams. So you decide, okay, I'm going to graph that. 9 pi over 8. I'll open up an angle all the way to 8 pi over 8. Here's 8 pi over 8. It's rotating over to 8 pi over 8 plus some more. And that plus some more, again, is critically important here, right? Because that plus some more allows you to know what you've overshot by. And we have overshot by pi over 8. Because 8 pi over 8 plus pi over 8 is 9 pi over 8. And there we go. We have our reference angle for 9 pi over 8. It is pi over 8. And so you can see that pattern. Now, I just want to say that again, is not always true. I can easily make an example. For example, let's see, theta is equal to, let's make it, let's do 11 pi over 9. So you would normally say, somebody would look at this and say, oh, pi over 9 must be the reference angle. The question is it pi over 9? Well, let's find out. So drawing the XY axis, you know that pi, right over here, is 9 pi over 9. So you know you're going to go beyond there. Our angle opens up, goes to 9 pi over 9, and then some more. But the some more on this case is an additional 2 pi over 9. And so that's our reference angle here, theta hat, is not pi over 9. It's actually 2 pi over 9. So you do have to watch out. If the difference between these numbers is greater than 1, then it likely is not going to be just a pi over the denominator. But the difference here was 1, so it became a pi over 8. Difference here was 1, so it became a pi over 3. This difference wasn't 1, but it's because twice 6 is 12. And so difference between 12 and 11 is 1, so that's why it does work out. But I highly just recommend to graph. That's the best way to do it.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close. Don't talk too much that isn't cold. Sure, you may really hurt inside. It doesn't justify you to speak too loud and cry.